Welcome to a new course. In this course, we will cover the Pandas library of Python, from basics to advanced usage. I will add chapters to this video, so if you want to skip some parts or re-listen some of them, you can find timestamps in the description. So what is Pandas? Pandas is an open source library that provides powerful data structures and data analysis tools for Python programming. It's particularly designed for working with structured or tabular data. If you're doing any data related thing in Python, you probably heard about Pandas before. Let's start coding. We will start by installing Pandas. To install Pandas, you first need to ensure you have Python installed on your system. Once Python is set up, open your command line or terminal and execute this command. I'm going to open my terminal and I'm going to say pip3 install pandas. Sometimes it works with pip, not pip3, so you can try that if it's not working. And when pandas is installed, we can close our terminal and we can start to our course. This statement allows us to access all the functionalities provided by the pandas library throughout our code. After the installation is complete, you can verify it by importing the pandas library in a Python script or a Jupyter notebook. We are going to use a Jupyter notebook for this course because seeing things cell by cell is more educative and informative, I think. I generally prefer using Jupyter notebooks when I'm coding. Okay, we are going to import our library. We are going to say import pandas and we will say pd. This line of code imports the pandas library with the alias pd, which is a common convention among the pandas community. You can also check the version of pandas that you have installed by running this command. You will say pd and you are just going to say version with 2 underscores and you can see the pandas version. This command will display the currently installed pandas version on your system. Now let's explore the process of creating a pandas series. At the first steps, when we are creating series and data frames, I'm going to create them manually by writing, but after, when the times go over with the course, I'm going to just make copy pastes for the data creation for making this course short and more efficient. So, what is series? A series is a one-dimensional array-like object that can hold various data types, including integers, floats, and strings. So let's say my series, and we are going to say pd, we will use series. You need to use capital letter for the s, and we are going to give values like 10, 20, 30, 40, 50, and we are going to set index here, and let's set index like a, b, c, d, and e. And now we can get our series displayed. This will create a series with the provided data and display it on the screen. So let's check its type like type my series, and you are going to see that it's going to be series object. You can also specify custom indices to label your data points, enhancing the accessibility of the series. Pandas series support both label-based and position-based indexing. You can access specific elements for a range of elements using their labels or positions. For example, let's access our elements by label. So for that we will say my series, and with using brackets we are going to say, let's say we are going to take the value of the index a. And as we can see, the index a has the 10 value. So let's slice elements by label. We are going to see this in more detailed version in a second in the course. So let's say b and let's say d. This time we are going to take elements from b to d, including both. These operations allow us to extract specific data points or subsets from the series efficiently. Pandas series facilitate element-wise operations, allowing you to apply arithmetic operations to the entire series at once. So, for example, let's firstly call our my series, and then let's say we are going to add 1 to every element. So we will say my series plus 1. Like, it's this easy. We can add a constant value to the series this easy. Also, let's do a multiplication like my series multiplied by 2. And also we can do division like my series, and we will say divide by 2. Here it is. We can do a lot more with series. So let's display the data type of the series elements. So we will say my series, and this time we are going to use data type. And here it is, we have integers in our original series. Like, let's just display it like this, and you can see that we have integer values. Also, we can check it like, let's reach to the first element we got, and let's check the type of it for seeing if it's integer. And we can see that it's an integer. Great. We can determine the size of the series. We need to use my series, and we will say size this time. And it's 5 because we have 5 elements in our series. Here it is, we have 5. We can get the shape of the series. Like, we can say my series.shape. Here it is. Understanding the data type, size, and shape of your series provides valuable insights into the nature and structure of your data. Pandas series offer a wide range of methods for efficient data manipulation and analysis. Let's explore some of these methods. For displaying the first few elements of the series, we can use .head method. You are going to see this a lot when you are using Pandas, and when we use that, it displays 5 entries, but you can see the difference like with this because we only have 5, and in the parentheses, if you say like 3, you are going to display 3 elements. Similar to that, if you say .tail after series, you are going to get the last items, but let's say 2 this time inside the parentheses, and you will get the last 2 elements. Also, you can get the descriptive statistics for the series if you have numeric values. Like, we can say my series.describe, and let's just run this. You are going to see that we have the count, mean, standard deviation, minimum value, quartiles, and the maximum value here. So what else you can do is you can just say my series, let's call it, and you can say .sort values, and this is now sorted in ascending order. For sorting in descending order, you can just say ascending, and you will need to set it as false, and when you do that, you are going to see that it's going to display the series in a descending order. These methods enable you to quickly gain an overview of your data, visualizing a deeper understanding of its characteristics and distribution. Now we will focus on creating data frames, a key data structure in the Pandas library from various data structures. This is going to be the thing that you will see most as the data type when you are working with Pandas or in any data-related operation. Understanding how to efficiently construct data frames is crucial for handling and analyzing complex datasets. Let's start by creating a data frame from a Python dictionary. So let's create a dictionary like data, and we will say name. By the way, I'm going to say this again. I'm doing it manually because we are just starting to the course. After that, I'm just going to make copy pastes for these operations. Emily, let's say Kate, and let's say Sam. Then we can do age, and we can say 25, 30, 28, and 35. And let's say city in here, and we can do New York, and let's say San Francisco and Chicago, and what else we can say, let's say Seattle. And here is our dictionary. We can see our dictionary have name, age, and city. These are going to be our columns, and John, Emily, Kate, Sam, 25, 30 are going to be our values. So for creating a data frame from a dictionary, we are going to say data frame equals to pandas.dataframe, just like series, but you need to use capital letters on both D and F, and then we are going to say data. It's this easy, and when we call data frame like this, we are going to see that our data frame is going to be created. This code snippet demonstrates how to create a data frame from a dictionary where keys represent column names and values represent the data in each column. So let's talk about it. We have indexes in here like 0, 1, 2, 3. We have columns name, age, city, and we can see our values in here. You can also construct a data frame from a list of lists. Consider the following example, like we can say data list, and we are going to open a bracket for creating a list. Then we are going to create another list inside, like let's say John, and let's just do the same with the upper one, John, and 25, and New York. And let's do Emily. Also, we need to create a new list for this. So I'm just going to close this one. Then I'm going to say new list, Emily, 30, and San Francisco. And then what else we can do is we are going to create a new list like this. We will say Kate and 28. Normally I wasn't going to write all of them, but just for showing you that both methods are same, I'm going to do that. And at the last part we will say Sam 35, and we need to add Seattle to that. Seattle. Okay, great. Now we have our list in here. Let's just call data list and see what it looks like. It looks similar to these values, right? We just need to give columns to this. So let's say we will use like Dataframe list, and I'm going to say pandas.dataframe. And I'm going to say data list is going to be the values that my data set is going to be created on. Then I'm going to say columns, and I'm going to give them their name. Like we can say name, we can say age, and we can say city. And when we run this data frame list, you're going to see that it's similar with this. Actually, they are not similar, they are same. When we call data frame, they are both same. Using this method, you can customize the column names and explicitly define the data structure. Pandas also enables the creation of data frames from NumPy arrays. So let's do that. Let's import NumPy as NP, and NumPy is really popular if you are doing a data related thing in Python. Let's create an array like numpy.array, and we are going to say 2 brackets 1, 2, 3, and 4, 5, 6, and let's say 7, 8, 9. I think it's enough. And when we call our array like this, you're going to see that we have this array. And what else we are going to do now is we are going to say data frame array, and we will say pandas.dataframe again, just like in the lists. We are going to say data array, and we are going to say columns. We will say A, B, and C. And let's call our data frame array. So here it is. We have our data frame right now. Also, you can check type of the data frame, like you can say type, and you are going to see it's a data frame. Here it is. So we said columns in both list and NumPy array, but we didn't say it in the dictionary side. That's because in the dictionary side we are giving these labels, like these are going to be columns, but in the other ones we don't have them. Like in this list we have nothing like name, and in this array we don't have nothing like, we don't have anything like A, B, and C. So with this method, you can easily convert NumPy arrays into data frames. Now we will explore the process of loading data from various file formats, such as CSV and Excel, into Pandas data frames. Understanding how to efficiently import external data is essential for real-world data analysis tasks. Let's begin by demonstrating how to load data from a CSV file. So, since we changed our data frame a little bit, like we didn't change what we used other ones, I'm just going to make a copy paste again for creating the data, and seeing this again and again will help you on remembering the codes. So I'm just going to create a data frame like this. We have a dictionary, name, age, city, same data set, and I'm just going to run this, and here is our data frame again. So I'm just going to open Explorer from here, and you are going to see that we have no files in here, and I'm just going to write my data frame to a CSV file, and then we are going to see that our file is going to be in here. I'm going to say dataframe.toCSV, and I'm going to say example.csv, and we need to set index equals to false if we don't want these indexes to be written on our CSV file. I don't want that. I generally don't use that. And when I run this code, you are going to see that my example CSV is going to be displayed in here. So let's check how it looks like. I'm just going to click on it, and you can see that we have name, age, city, John 25, New York, Emily 30, San Francisco, etc. I actually made a change, I'm just going to reverse it. And so, great, we've written our data frame to a CSV file safely, but what if you want to read it back or read it from another data file? You are going to use this command a lot. We are going to say data, and let's just use PD. We are going to use read CSV, and we are going to say example.csv. And when we use that, and when I call the data, you are going to see that we are going to have the same data frame. Actually, we have this space in here, so if we change it from the original CSV file we are reading and save it like that, you are going to see that it's going to be fixed in here. So my file is not saved, I think. I'm just going to make command and S for saving that, and now it's going to be fixed, I think. Yes, great. This example demonstrates how to create a data frame, save it as a CSV file, and then read the data back into a new data frame. Next, let's explore loading data from an Excel file. It's also a thing you are going to do a lot when you are working with data. So again, we need to write it to an Excel file. So I'm just going to say data frame. We are going to see our data frame again. I'm going to use to Excel this time, and we are going to say example, and we need to write XLSX or any other Excel formats. I don't remember any of them. And I'm going to say index false again, and we are going to say example.xlsx is going to be in here. And when I click on that, I think I don't have any Excel viewer in my VS Code. So I'm just going to try open anyway, and it's going to show a different thing. Okay, but I'm just going to show you this file in a second. So here's my Excel file that I just created. So in the original data frame we have the space, as you can remember, and now we can see our data frame is in an Excel file format. So I'm just going to jump back into the VS Code right now. So what I'm going to do right now is I'm going to say data Excel, and this time I'm going to use read Excel command, and I'm just going to say example.xlsx. And when I call this data Excel, you're going to see we have this original data frame again. Also, since this looks bad, I'm just going to do like rename, and we are going to say columns, and let's say age, and actually the original name of it is like this, and let's say age instead of this without spaces. And I'm just going to run this one, and it's going to look better. I'm going to show you these methods in the later stages of the course. It was just fixing for the visual thing. So we can close this. Okay, this code snippet showcases the process of saving a data frame to an Excel file and subsequently reading the data from the Excel file back into a new data frame. Pandas also supports various other file formats, including JSON, SQL, HTML, and Parquet files. You can utilize appropriate methods such as pd.readJSON, readSQL, and readHTML to load data from these formats into a data frames. Now we will delve into the basic operations that can be performed on Pandas data frames. These methods are the ones that you are going to use a lot when you are doing a data analysis. Application. Understanding how to view data, select specific rows and columns, and apply filtering techniques are essential skills for effective data manipulation and analysis. So let's just create our data frame again with the same code. I'm just going to recreate it in different sections for remembering the data frame and showing you this data creation code. And let's start by exploring how to view data within a data frame. So for displaying the entire data frame, you already saw that we can just write data frame in the Jupyter notebook, and you will see the same. So we just use the head method with a series, and we can just use dataframe.head like the series one, and it's going to display the first 5 rows of the data frame, and I'm just going to write 2 in here. So you are just going to see the John and Emily. So we also have tail like in the series, and let's just change this 2 with 1 for getting the Sam in here. Great. These commands will allow you to view the entire data frame as well as the first and last few rows, providing an overview of the dataset. Pandas provides various methods for selecting specific rows and columns within a data frame. So let's make example with this. For selecting specific columns, we can just say data frame, we can use two brackets, and we can just say name and city. And you are going to see that we are not going to get age when we run this code. Here it is. So you can also select one column like this. And we are going to get the name values in here. But there's something important that if you use this with two brackets, it's going to return a data frame. Let's just quickly check this. When you use that, it's going to return a data frame. And if you just remove one of the brackets from both sides, like if you delete this and delete this, and when you do that, you are going to get a series. So if you do type on this, you are going to get the values inside of that column as series, just like in here. Also, let's just filter with two brackets. Again, for getting a data frame, I'm just going to show you another method. I need to put a bracket on there, and when we run this, we are going to get a data frame in here. If you want to get these values, you can just use .values after that, and you will get the values like John, Emily, Kate, and Sam. Actually, I think I need to remove the parentheses after that, and here it is. We got an array of that values. Okay, with that being said, let's go our data frame, and let's just say we want to select specific rows based on conditions. Like, let's pick the entries, rows when I say entries, with the age greater than 28. So what we are going to do is, we will say data frame, we are going to open brackets, then we are going to put our condition in here. I'm just going to say data frame age, we are selecting the column values like this, and I'm just going to say greater than 28. And when I run this, we are going to get the ones which is greater than 28. Actually, Kate is 28 years old, so if we just put a Q sign in here, we are going to get the Kate also. These operations enable you to extract specific subsets of data based on your defined criteria, facilitating targeted data analysis. Let's do some operations with these. Also, we will see more filtering operations you can use. I will explain them briefly in the next parts of this video. So let's filter our data based on a specific condition again, like let's say data frame, and we are going to say data frame, let's use name this time, accused to John. And here we got the entry with this information. Also, you can just say Emily like this, and you will get the Emily this time. Okay, so what else we can do is, we can filter our data using multiple conditions. Like what we can do is, we will say data frame, and we will use brackets again. And for each condition, we need to put parentheses, and we are going to say data frame, city, accused to New York, and we are going to use the AND operator after parentheses. And I'm just going to open a new one, and let's see which entry lives in New York, and let's just say data frame age is less than 30 for getting the John. And here it is. Also, if you just change this to 20, you are going to see you will get nothing, because one condition here is satisfied, but the second condition is not satisfied, and we are using the AND operator. So we need to get both conditions true for getting that entry. Okay, let's filter rows using the isIn method. So I will say, let's say selected, actually let's call data frame again for remembering it. I will say selected cities, and I'm just going to say New York and Seattle. And I'm just going to filter the data like this. I will say data frame city, and I will use isIn method. Then I will say selected cities, and you are going to see we get the selected cities. We can change this like Chicago, and when we run this, you are going to see the filtered entries are going to change. We can also filter rows using string methods, like let's say data frame, and let's say data frame name, and we will use .string. Then we will use starts with method, and let's just say J for getting the John. Here it is. We filtered rows where name starts with J. Also, we can change this like K for getting the Kate. Great. We can also select specific rows based on index values. Like, let's just call our data frame again. You can see these are our index values. Like John has the index 0 and Sam has the index 3. For that we will use dataframe.iloc. I also have a specific part in this course for this loc and iloc. You can just watch right now and you are going to understand how it works. After that we are going to say 0 and 2. We get the indexes 0 and 1 but not 2. This is not included. It's like 0 to 2. Also let's use loc. Since I talked about it, we can just say dataframe loc and we can just use dataframe and I will say age and I will do greater than 28. Let's say you don't want to get the entire columns with this. You can just select like name and city from here. Like you will not get the age after this. Here it is. These examples illustrate different ways to filter data within a Pandas data frame based on specific conditions and criteria. Incorporate these techniques into your data analysis workflow to efficiently extract meaningful insights from your datasets. We are going to talk about them more in the video. Now we will focus on handling missing data within Pandas data frames. Dealing with missing values is a crucial step in data processing and analysis, and Pandas provides several techniques to address this issue effectively. Before we delve into handling missing data, let's first identify the missing values within our data frame. So we are going to take the help of NumPy for creating missing values. We already imported it, but let's just import it again. Import NumPy as np, and how we can create missing values in NumPy is we can just use numpy.nan and it creates a name which we can also refer as missing value. So I'm just going to make a copy paste again, and in here we have missing values in every column as you can see. And for checking missing values you can just say data frame and is null like this, and you are going to see you are going to get booleans for each value in here, and if it's a missing value like in this one you will get true, otherwise you will get false. This will help us identify the locations of missing values in the data frame. If you want to see the counts, you can use .sum after it. Like you can just say data frame is null, and after that you can use .sum and you will get the counts. Like we have 1 in A, 1 in B and 1 in C, as you can see. One approach to handling missing data is to drop the rows or columns containing missing values. Also, if you are going to do any type of change in dataset that you want to change after now, you either need to use in place or reset it. I will show it to you in a second. So let's just keep with dropping the NA. If you want to drop the values that you don't want to use, you can just say drop NA and it's going to drop the entire rows which contains NA values. Like we have NA in the index 3, index 2 and index 1. You are going to see this 3 is dropped and we only get the 0 and 4. But when you call the original data frame, you are going to see that these chains are not set in the original data frame. Like we have the indexes 1, 2 and 3. If you want to save it, we can basically use in place equals to true after the drop NA. So what we can do is we are going to say dataframe.drop NA and we will use in place equals to true inside the parentheses. And when we do that, we are going to see our original data frame is going to be updated. Also, we have another way for this. Let's just recreate our data frame and we can just use dataframe drop NA like this. You know, this is not going to change our original data frame, but if you reassign it to the data frame like this, df equals to dataframe.drop NA, you are going to see that you will have a data frame without non-valued rows like this. Great, let's recreate the dataset with NA values and see other dropping methods. Here we have the data frame with NA values. Let's drop the columns with any missing values. In our case, all of our columns is going to be dropped because we have null values in 3 of them. So we will say dataframe.drop NA, and this time we are going to say access equals to 1 in the parentheses, and you are going to see that we have no columns left. So if you change this to 0, you are going to get rows deleted 1, 2, 3. Axis 0 is rows and axis 1 is columns. You can remember that for the future usage. Also, you can drop rows with a threshold of non-missing values. Like if you say Dataframe.drop NA and you will set threshold as 2, you are going to see that none of are going to be dropped because there is no 2 NA values in a row. Like if you just change this numpy.nen with this one too, and you are going to see that right now. I'm just going to call the data frame again, and I'm just going to show you the A and B is NA for the 2, and when I run this, it's going to drop the row 2. So if you just do like 1 in here too, let's just say 3 for displaying it again, you can see 1, 2, 3 is dropped right now, and you can just say 1 like this and you will get none dropped. Great. These methods allow us to selectively drop rows or columns containing missing values based on specified conditions. Another approach is to fill in the missing values with appropriate data. So let's do some examples with it. Let's call our data frame again, and you will see that we have NA values right now, and let's just say dataframe.fill_NA, and let's just use 0 for filling the NA valued rows with 0. You can see our NA values are 0 right now, but it's not originally modified on the data frame. So if you want to do, you can use in place equals to true, but I'm not going to do that because I'm going to show you more methods of filling, and here it is. So let's just move into the next one. We are going to fill the missing values with the mean of the column. It's commonly used for filling the missing values. Also median is commonly used. I'm going to show you that too. We will say dataframe.fill_NA, and we will use dataframe.mean, and you will see that our NaN values are going to be filled with the means of the columns. Also for the median, you can just use dataframe_fill_NA, and you will see dataframe.median, and when you use that, you are going to fill the NA valued rows with the median of that column. Like the median value of the B column is 9, like in this case, the NA values are going to be filled with the median right now. Also, you can use different aggregation functions like maximum or minimum with fill_NA method. Also, we have a filling method like forward filling. I'm just going to show you that. You will say dataframe_fill_NA, and we will say method is going to be equal to the forward fill right now. What this does is, I'm going to show you with the original data frame right now. It just fills the next value with the upper value, like this is 6 in here, then NA comes, it fills this NA with 6, and for the other it just checks, for this it checks this one, B1, and then it fills B2 with 6. Also we have something like backward fill, and when you do that, it's just the reverse of it. It just checks this value, and the below value is 9, so it fills this one with 9, and then it checks for the B1, it checks for B2 for the B1, and it just fills it with 9. These techniques provide flexibility in filling missing values with meaningful data, ensuring the integrity of the dataset. Now we will focus on data manipulation using the powerful loc and iloc methods in Pandas. Understanding how to effectively use these methods is crucial for performing advanced data operations and analysis within data frames. Let's start by exploring the loc method for label-based indexing. So I'm going to create an example data frame again, and we are going to work with this right now. Let's access a specific row. For that, we will say dataframe.loc, and let's say A. And here it is. So we got the 1, 6, and 11 from here. Okay, let's access to multiple rows. So for that, I will just say A and B, like this. Actually, I need to use this instead of comma, and this time it's going to work. Now we have 1, 6, 11, and 2, 7, 12. This is for slicing rows. So if you say C in here, you are going to get the values between them, like this. And for selecting multiple rows, like the old example, we need to use comma, but we need to use two brackets. Like we can just use two brackets for accessing multiple rows, like this. Also, you can just pick like E with A. You don't need to get the between values. Like in this example, we get this one and this one. Okay, let's see the accessing to specific rows and columns together. So for that, we got the A and E here. So, and let's just say we want to get B and C as the columns, not A. So for that, we can say B and C, like this, for getting that information. Here it is, we didn't get the A. Also, you can just change this as A and you will get the A instead of B. These operations enable us to select specific rows and columns based on their labels within the data frame. Now let's explore the iloc method for position-based indexing. So I will just say data frame for the iloc part, and I'm going to say, like, let's just say we want to access to the first row. So we will say data frame.iloc and we will just say 0 in here. Here it is. Don't forget that indexes start from 0 in Python. Like if you want to get the first of this, you need to use 0, and if you want to get the second, you need to use 1 instead of it. Okay, let's see the accessing to multiple rows. Let's just say 0 and 2, and we need to use double brackets like this. And when we run this, we are going to get the 0 and 2, A and C. Here it is. Let's see how we can slice the rows. I'm just deleting one of the brackets and I will say 0 to 3. It gets 0, 1, 2 indexes, but not the 3. Remember it like 0 to 3, but not 3. And for the accessing specific rows and columns, we can just use, let's just say, we will use double brackets 0 and 2. And you are going to remember that we get A and C. And this time, like the log 1, I will use comma, then I'm going to say 1 and 2 for getting the B and C. And if I just change this to 0, we are going to get the A again instead of B. These operations allow us to select specific rows and columns based on their positions within the data frame. Now we will delve into advanced techniques for conditional filtering and querying within the Pandas data frames. Mastering these methods is crucial for extracting specific subsets of data and performing complex analysis on datasets. Let's start by exploring conditional filtering using Boolean indexing. Before that, I need to make a copy-paste from my clipboard like this for creating a data frame. You're going to remember this data frame. Here it is. Let's filter the rows based on a specific condition, like you are going to remember this one. We will say data frame and we are going to open brackets, then we will say data frame age. And let's say like less than 32. And here we dropped this row Sam because his age is 35. And let's apply multiple conditions like we did earlier. I will say data frame city, and also I need to use data frame brackets before this. And we are going to say city is going to be equal to the Chicago. Also, we need parentheses. Since we are doing multi-condition filtering, we need to use open and operator, then we need to open parentheses. Then we are going to say data frame age less than 30, and we will get the Kate in here. Remember that if we just change one of this, like Chicago with New York, you are going to see that we are not going to get any results because actually both conditions are true for the John. Let's just say age less than 24. We are not going to get any returns right now because one condition is satisfied for John, but the other one is not satisfied. So it returns nothing since we are using AND operator. These operations enable us to extract specific subsets of data based on complex conditions within the data frame. Pandas provides the query method for advanced querying, and if you are familiar with SQL, you are going to love this method. Let's just use query like dataframe.query, and we will say age greater than 28. When we run this, we are going to get the ones with the age greater than 28. Also, we can use the query method using multiple conditions like the old one. Let's just say dataframe query, and we will say age greater than 28, and let's say and city equals to San Francisco. Actually, we need to use quotes like this for this to run because it's a specific value. We need to put it before the city name, and when we run this, we are going to see we got the Emily. But if you want to say like I want to get the entries which satisfies either this or this condition, you can just use or instead of the and you will get the everyone which satisfies one condition from here. Like Sam is at the age of 35, so it came, but it's not living in San Francisco. You can also query with arithmetic operations like let's say dataframe.query, and we can just use like age multiplied by 2 greater than 50, and we are going to see the rows which has the age 2 multiplied version is greater than 50. Now we will explore the techniques for sorting and ranking data within Pandas data frames. Understanding how to effectively sort and rank data is essential for organizing and analyzing datasets in a meaningful way. Let's begin by examining how to sort data within a data frame. Let's just call data frame again. Actually, I need to call data frame, not SD. Here it is. Let's sort our data frame by specific column. Let's say sort values, and we will say age in here. And we can just use ascending with this. Ascending false for sorting it in descending order based on age. This is a way of it. And let's say we want to sort the data frame by multiple columns. So we will say data frame sort values, and we will just give a list like the columns. So this one sorts the data frame first by city and then by age. And if you give category columns like this, it will sort the data frame in alphabetic order. These operations enable us to arrange the data frame based on specific column values, facilitating data organization and analysis. Next, let's explore the process of ranking data within a data frame. So let's rank the data frame based on a specific column. For that, we will say data frame age, and we will use dot rank. And when we do that, you are going to see that our data frame has the ranks, and we can just handle ties via ranking. Like we can just say data frame age dot rank, and we will say method is going to be equal to minimum this time. You can see it's changed. This handles ties by assigning the minimum rank to tied values. Ranking data allows us to assign numerical ranks to the values in a specific column, providing insights into the relative positions of data points. Now we will focus on the techniques for combining and merging data frames in Pandas. Understanding how to effectively merge and concatenate data is essential for integrating and analyzing complex datasets. Let's begin by examining how to concatenate data frames. So I'm just going to create two data frames like this, and I'm just going to run this one, data frame 1 and data frame 2. Here we have two data frames. Let's concatenate data frames along rows. So for that we will say pd, we are going to use the concatenate method, and we will say data frame 1 and data frame 2. For concatenating data frames along columns, we are going to say pd.concat, and we will say data frame 1 and data frame 2. This time we are going to set the axis as 1. These operations enable us to combine data frames either along rows or columns, facilitating the integration of data from multiple sources. Next, let's explore the process of merging data frames. So for that, I'm just going to create a new data. Like here, we are going to have the data frame 3, and you are going to see a similarity between data frame 1 and data frame 3 is that A columns values are the same within these. So we are going to merge data frames based on the A column. We will say pandas.merge, and we will say data frame 1 and data frame 3, and this time we are going to say on A. So what happened in here is we just merged this data frame 1 and data frame 3 on A column, and this time we have B and C here. Merging data frames allows us to combine data based on common columns enabling comprehensive analysis across related datasets. Now we will focus on essential data cleaning techniques within Pandas. Data cleaning is a crucial step in the data processing phase, ensuring data integrity and accuracy for further analysis. Let's begin by exploring how to remove duplicate values within a data frame. I will create a data frame like this, and I'm just going to call this data frame, and you are going to see that we numeric values in values like this index 1 and 2 are duplicates, and in terms of columns, like these values are duplicated in A column, these values are duplicated, and in the B column these values are duplicated. For removing the duplicate rows, we can use Dataframe.dropDuplicates method, and you are going to see that we won't have duplicates after it. Let's say you want to check the duplicates in your data. So for that you can say Dataframe duplicated, and it's going to return booleans like true and false, and if you use that sum after that, you are going to get the actual number of duplicated rows. So if you want to remove duplicate rows based on specific columns, like if you want to remove duplicates on the A column, these two and these two are going to be removed. You can do it like Dataframe.dropDuplicates, then you need to say subset, and you need to say A inside here, and you are going to see that these columns values are dropped, like this one and this one are dropped because they are duplicates. These operations enable us to identify and remove duplicate rows based on specific criteria, ensuring data accuracy. Next, let's explore techniques for handling outliers within a data frame. So let's quickly call our data frame again, and I'm going to work on the B column. Let's check the values for the B column, like we have minimum of 4, maximum of 7. We got the 75%, 6 and 25% 5 in here. So we will take this quantile and take this quantile. Then we are going to filter our data based on that bounds. Like our bounds are going to be maximum value plus 1.5 multiplied quantile range, and quantile minimum minus 1.5 quantile range. By the way, quantile range is maximum versus minimum, like it's going to be 3. Okay, we can just do that. Let's say quantile low, and it's going to be data frame B, and we will use dot quantile, and we will say dot 25. And for the quantile high, we are going to say data frame B, and we will use quantile 0.75. Also, let's recreate our B quickly. Like I'm just going to delete this, and I will say B and A are going to take values like 12, 10, actually it won't change anything, like, and let's say 1 in here, and let's also say 25, just for seeing the filtered version, because if we keep like that, the numbers are so close and there is a situation that non-data will drop. So I'm just going to rerun this. We got a problem. I need to add one more number in here. Now it's going to be fixed, and here is our new data frame, and now we can work on it. Also, we need to rerun this because the values are changed. Like if I say data frame describe this time, all the values are going to be changed, and our interquile range is going to be 25 versus minus 1. It's going to be 24. Okay, let's say quantile range is going to be equal to the quantile high minus quantile row. So, by the way, I just recognized that I was telling quantile thing wrongly. Let's just call describe. The quantile range is this minus this. 75 quantile minus 25 quantile. Not maximum minus minimum. It was something different, I'm sorry. And now we can do lower bound, and it's going to be equal to the quantile low minus 1.5 multiplied quantile range, and lower upper is going to be, actually let's call it like upper bound, and it's going to be quantile high plus 1.5 quantile range, and we are going to filter this. we will do, as you already know, multiple filtering operation, like let's say df filtered, and we are going to say data frame, and we will say parentheses for the first condition, data frame b greater than lower bound, and operator df b less than upper bound. Also, let's display the data frame before getting the filtered version. Like, also display this df filtered, and you are going to see the difference, like 25 is dropped. Handling outliers using quantiles allows us to identify and filter out data points that fall outside a certain range, ensuring the data's reliability for analysis. Now we will focus on the techniques for handling categorical data within Pandas. Understanding how to effectively manage categorical variables is essential for various data analysis and modeling tasks. Let's begin by exploring how to encode categorical data. So I'm just going to create a new data frame, and let's call it. We can see that we only have categorical values in here. So let's start with encoding categorical data using getDummies method. We can use like pandas.getDummies, and we are going to say data frame category like this, and you are going to see that we have 3 columns, and you are going to see that each unique value in here in columns, and if it's a in the original data frame, it's true in here. If it is not, it's false. Actually, for knowing the third class, you only need 2 of this. Like, you can just say a and b, and this will give you information about the c, because if it's false, if it's true, c is going to be false in here, and if it's both false, the c is going to be true in the third index. Like, you can use it like this. Also, I'm going to show you another encoding method. This one is not going to be from Pandas, it's going to be from scikit-learn, but it's something useful, so I just want to show it quickly. We can just say from sklearn.preprocessing import label encoder, and initialize this label encoder like encoder label encoder class. Then we can just do data frame category and label encoded, and it's going to be label encoder dot fit transform. I'm going to record the scikit-learn course soon, so I'm just going to cover all this, and we are going to say data frame category. And let me quickly show you the original data frame and this version. Now this is the original data frame, and when I run this and we recheck this, you are going to see that we got values like 0 for A, 1 for B, and 2 for C. I just wanted to quickly show you this because this is the most used one. So these operations enable us to encode categorical data into a format suitable for various data analysis and modeling tasks. Next, let's explore techniques for handling categorical data for analysis. So let's just call our data frame again by recreating this, and let's call it in here, and we can just analyze categorical data using group by. Actually, let's just create new features into our data, like let's say sales, and we can just do like 10, 20, 30, 40, 50, and 60, and recreate this data frame quickly, and we are going to have the values. Now what we can do is we can just say data frame.group by, and we can say category, then we can use .size, and you will see the counts in here like A, B, A, C, B, A. Actually, let's not use the sales in this particular part of the course. I will use some grouping operations later on, so let's just forget about it. And what we can do is we can also use aggregation functions like data frame group by category, and we can use .aggregation, then we can say category, and we can say count. This is going to give the same result with the upper one. This gives a series like category 3, 2, 1. This gives a series with this index. Actually, I think it's data frame. Let's quickly check this. Type You can also check the data types in Python like this, and it's a data frame. So I'm just going to quickly show you a method like this is now a series, like we can check. And what if we want this to be data frame? We can basically use like reset index method, and this time this ABC is going to be in a new column. Our indexes are going to be into columns. Like you can see it's a data frame now, and you can just use type, then you are going to see it's a data frame from now on. Great. These techniques enable us to analyze categorical data effectively, providing insights into distribution and characteristics of categorical variables within a dataset. Now we will focus on data transformation techniques in Pandas. Understanding how to reshape, pivot, and melt data is crucial for organizing and restructuring data for various analytical tasks. Let's begin by exploring how to reshape data within a data frame. So I'm just going to create a new data frame, and I'm just going to call it like this. And now we are going to reshape the data using the melt function. So I will say pandas.melt, and I'm going to say data frame, and ID variables is going to be equal to the name, and I will say actually I'm in list. I will say variable name, and I will set this as subject. Then I'm just going to do value name is going to be equal to the score. The melt function allows us to reshape data by converting columns into rows, facilitating a more organized representation of data. Next, let's explore how to pivot data within a data frame. So I'm just going to set this like data frame melted, and now I'm going to use pivot on that. I will say it's just like in the Excel, data frame melted. Actually, for seeing it visually, let's also call this, and I will say data frame melted dot pivot, and index is going to be equal to the name, just like Excel. I will say columns is going to be equal to the, actually I made a typo, I'm quickly changing that. Columns is going to be equal to the subject, and value name is going to be equal to the score. Actually, I need to use like values, and now we can see that we got the pivot table we wanted. The pivot function allows us to reshape data by converting unique values into new columns, providing a different perspective on the data. Now we will focus on handling date and time data in Pandas. Understanding how to effectively work with temporal data is essential for time series analysis and various time-based operations. Let's begin by exploring how to work with date and time data within a data frame. So I'm going to create an example data frame with date and time data, and I will just say data frame here. We got the dates and sales related to that. I'm going to convert the date column to date time format. So I will say data frame date. And then I'm going to say pandas to date time. Data frame date. Actually, I need to use normal parentheses for that. And then I will say, actually before that, I will say data frame dot data types. Firstly, before that, you can see date is object and sales is integer. And then I'm going to do this, then I will say data types. And now we have date time in here. Okay, let's extract components from date time. Like we can get the year, month, and day after changing this to pandas date time object. Like let's add a new column as year, and we are going to say data frame date, and we will use date time dot year. And also we can do the same for the month and the day. I'm going to do that by copying. I will change this like month, then I'm going to change this with month. Also for the day, I will change this with day. And let's see the new version of our data frame. These operations enable us to convert date and time data into a more usable format and extract specific components from date time for further analysis. Next, let's explore working with time series data. Let's create another time series data and let's just check it, like time series data. This time we have series. Now we are going to see the resampling. So I will say time series resampled, and I'm just going to use time series data and I will use resample, and by the W we will say weekly. Then I'm just going to take the mean of it and I will say time series resampled for displaying it. You can also do this like monthly, yearly, and other time frames. Working with time series data allows us to analyze and manipulate data points based on their temporal characteristics, visualizing various time-based operations and analysis. Let's create another data frame similar to this series and do more examples. I will say data frame with this code here, and we have a data frame right now. Let's create a date time index like data frame date. We already saw that. We will say pandas to date time and we will say data frame date, and here it is. And now we are going to see how we can set this as index. So I will say set index and I'm going to say date, and I'm going to use in place equals to true for modifying the original data frame. So when I call data frame, we will have that index in here. You can check your index like data frame index and you will see your index. Here it is. Let's see shifting and lagging time series. So I will say data frame, and what we are going to do is let's create a column like shifted sales, and we will say data frame sales, and we will use dot shift and we will say 1 for shifting it, and we will say data frame lagged sales, and let's say data frame sales dot shift, and this time we will use -1 for lagging it, and let's call data frame again, and you will see that we have shifted sales and lagged sales. Since we don't have any before date and after date on these values, these are none. Okay, with these null values being said, what we can do is we can generate a sequence of dates and times. For that, we have a function of pandas like let's say date range, and we can use just pandas.date range, and this time we will give starting point like 2023 1 and 1, and let's say periods is going to be 10, and we will set the frequency like let's say weekly. And actually there's an error, let me quickly check. I made a typo, like it's periods. Actually I made a lot of mistakes on that, and this time it's going to work smoothly. And let's see how our date range looks like, and we will talk about its components. The periods here will create 10 new points with this frequency. Like if you change this to 20, you're going to see that we have 10 more in here, and if you change this to monthly, you're going to see that these are not going to be weekly, these are going to be monthly. Also, you can create long dates like let's say 2023, let's not change it, and you can say 2000 in here, and when you run this you are going to see you will have a lot to 2189. Great. Now we will focus on understanding group by operations in pandas. Group by operations are crucial for aggregating and analyzing data based on specific criteria, enabling comprehensive data analysis and insights. Let's begin by exploring how to use group by for data aggregation. For that, I'm just going to copy a thing from my notes, and I will say data frame for displaying it. Also, I need to use lowercase letters, and here we got our data frame. Let's group the data by category and let's perform aggregation. Like we can say data frame group by, and what we can do in here is we can say category, then we will say dot sum for getting the sums. Like in the A category we have the 60 from the sum of this, and we have the 40 from this. We can just change this aggregation function like mean, and we will get the means like this. Also we can do median and maximum and minimum. We have a lot of aggregation functions like standard deviation, variance, and much more. Great. We can also apply multiple aggregations like Dataframe, group by, and we can just say category. And what we can do is aggregation, then we can give a list like sum, mean, and maximum. And this time we will not get anything because we mistyped it. I'm going to say brackets, and when I add this, it's going to work smoothly. Like when I run this code, it's going to look great. Okay. Grouping data allows us to analyze and derive insights based on the distribution and characteristics of different groups within the dataset. Now we will focus on aggregating data using various functions in Pandas. Understanding how to apply different aggregation functions is crucial for deriving insightful summary, statistics, and analyses from your datasets. Let's begin by exploring how to aggregate data using various functions. So I will say Dataframe again, and what we can do here is we can say Dataframe group by category, and then we can use aggregation, and we can get like value and sum. Also, I'm just going to copy this before running it, and here it is. Also, we can do mean, and we can do maximum, standard deviation, and much more. These operations allow us to apply various aggregation functions to derive essential statistics and insights from the dataset. Next, let's explore how to apply custom aggregation functions. So just like say custom aggregation, and we'll use lambda x max minus x minimum. And here we got the function. Now I will say Dataframe group by, actually before that let's call our Dataframe for remembering it, Dataframe group by, and I'm going to say category, and I will use dot aggregation, then I will say value, and it's going to be custom aggregation function we created. Here it is. So it made 25 minus 20 and 30 minus 10 for different categories. Applying custom aggregation functions enables us to derive specific insights and metrics tailored to the requirements of the analysis. Let's do more examples like apply multiple aggregation functions simultaneously. So what we can do is, let's say Dataframe group by category, and let's say value, and what we can do in here is that aggregation, and then actually I need to use this bracket aggregation. Let's give a list like sum, mean, and it's enough. I think actually we can give like variance with it, and result won't change. We will get it also that we can also aggregate data with custom functions using group by, like define a custom function like custom mean, and we will give the function values, and we are going to return sum of values divided by length of the values. And how we can use that is Dataframe group by category and value dot aggregation custom mean. Here it is. Okay, let's do a time series visualization. Like we can just create a time series data like this and recheck it. It's actually the same data we used, and let's explore time series visualization. So for that we will say import matplotlib.pyplot as plt, and we can just say time series data.plot, and it's going to be a line plot. Let's set a marker like this, and let's set a color like this, and let's set a line style like this, and I think it's enough. Let's say x label is going to be equal to the date, and y label is going to be equal to the value. Then we can also use plt.grid, and we can use plt.show. Actually, we got an error. I'm quickly checking it. It says it's a typo. Okay, I'm just going to, it's line type, not lines type. And when I run this, we got an error again. I'm just rechecking it. Line type is also not valid because it's line style. Okay, I'm quickly fixing it, line style, and now it's going to work smoothly. Great. So what this grid does is, when I remove this, you are going to see the background is going to be removed. And when I add grid, it's going to come back. I always use grid when I'm working with data. Like, the background is nice, I think. Now we will explore advanced data manipulation techniques using apply, map and apply map in Pandas. Understanding how to leverage these methods is crucial for applying custom functions, mapping operations, and element-wise transformations on data with data frames and series. Let's begin by exploring how to use apply for data frame operations in Pandas. I'm just going to create a data frame like this, and I will call data frame in here. And let's just use data frame apply, and we will say data frame dot apply for using the apply, and we will say lambda x multiplied by 2. And when we call data frame apply our data frame, we are going to see that all of our values is multiplied with 2. Using apply allows us to apply custom functions to each row or column in a data frame, facilitating versatile data manipulations and transformations. Now let's explore implementing map for series operations. Let's say series data, and it's going to be equal to pandas series. I'm not going to do a copy paste for this. I will say 1, 2, 3, 4, 5, and let's say mapped data is going to be equal to series data dot map, and we are going to use lambda again, x 2 power of 2, and let's, after getting the squared value of each element, we can say mapped data, and you are going to see that we have the 4 for the 2 squared, the 25 for the 5 squared. Great. Implementing map enables us to perform element-wise operations on series, providing a streamlined approach for data transformation and manipulation. Lastly, let's explore using apply map for element-wise operations on data frames. Like, let's recall our data frame, and we will say data frame apply map, and we will use data frame dot apply map method, and we will say lambda and x and x3, and let's get the data frame apply map. Here it is. Using apply map enables us to apply function element-wise to every element in a data frame, facilitating efficient and consistent data manipulations. Let's do more examples with this. Actually, apply is the most used one, so I'm going to create example with this. Let's create a new column as C with using data frame dot apply lambda row A multiplied by row B, and we will set the axis as 1. And let's recall our data frame. For seeing the C column, you will see that 2 times 20 is 40, 3 times 30 is 90. Great. Now we will focus on visualizing data with built-in Pandas tools. Understanding how to effectively utilize these tools is essential for creating insightful visual representations of your data directly within the Pandas environment. Let's begin by exploring how to create basic plots with Pandas. Let's create a data frame firstly and call it. And now let's create a basic line plot with Pandas. Like we already did something like that. Data frame plot, and we'll say x is going to be equal to year, y is going to be equal to revenue, and let's set the kind as line, and let's set the marker as this, and I think it's enough. Let's don't add another thing. We'll give this a title like revenue over the years, and let's give this a X label like year and Y label like revenue, and also add grid, then use plt.show. Here it is. You can change this things like you can do color, and you can say red for customization, and what you can do is you can do sky blue for this, and if you don't want to see this revenue thing in here, like let's do yellow, and actually we can see it, let's say black. And if you don't want to see this revenue thing in here, you can just say legend and set this as false for removing it, like this. Now we will talk more and focus on creating basic plots such as bar plots and scatter plots in Pandas. Understanding how to effectively create these plots is essential for visually representing data and analyzing trends and relationships within dataset. Let's begin by exploring how to create bar plots with Pandas. So here I have a data frame, and now what I'm going to do is dataframe.plot. I will say X is going to be equal to the city and Y is going to be equal to the population, and we are going to set the kind as bar this time, and let's say color is going to be the red, and let's say legend equals to false. Also what we can do is we can give it a title like population in major cities, and let's add X label like city and Y label like population, and we will use plt.show at the end. Here it is. So what if you want to sort them in descending order is you can just say data frame sort values, and by is going to be equal to the population. We are going to sort this by population, and we will say ascending equals to false, and we are going to plot like this. The rest is going to be the same, and we are going to get our bar plot in descending order. Also for getting it in ascending order, you can just change this to true and you will get it in ascending order. Creating bar plots with Pandas allows us to compare different categories or groups, facilitating a straightforward visualization of the data. Lastly, let's explore creating scatter plots with Pandas. So here we have a data frame, df scatter. Actually, I called the wrong one, scatter, and I'm just going to copy it. Okay, let's create a scatter plot for that. We will say plt.scatter. We are creating with matplotlib this time. I will say data frame scatter x, and I will say data frame scatter y, and let's say color is going to be green, and we will say x label as x, y label as y, and we will use plt.show. By the way, we are creating the scatter plot with matplotlib, not Pandas. So here it is. Creating scatter plots with Pandas allows us to visualize the relationship between two variables, facilitating the identification of patterns and correlations within the dataset. Now we will focus on working with multi-index data frames and combining Pandas with other libraries, such as NumPy. I think it will be just NumPy. I'm not going to add other libraries to this part. Understanding how to effectively manage multi-index data and integrate with external libraries will enable us to handle complex data structures and perform advanced data analysis. Let's begin by exploring how to work with multi-index data frames in Pandas. So I'm going to create a data frame like this, and I will say, as you can see, we have two indexes, first and second, and I'm going to say data frame.index, and when we do that, you are going to see we have A1, A2, B1, B2, like this one, and this with this, and this with this, and this with this. How we can do this is you can just use multi-index from Pandas, and you will say from arrays, and you will give two arrays as index, and then you will say arrays, and you will give names like you can just give first one and second one like we gave in here. Then you are going to set the index when you are creating the data frame with pandas.dataframe, and you are going to see that these are changed. Like also you can add more like D and C and B to this, and you are going to see it's going to be changed. Like you can just give two values for this and it's going to work finally. Actually not, because I forgot that we need to have same length arrays. Like we need to do like 3 and 4. This time it's going to work smoothly. Here it is. So when we call index, we will say A1, B2, C3, D4 this time. Working with multi-index data frames enables us to manage and analyze data with multiple levels of indexing, facilitating the organization and manipulation of complex datasets. Next, let's explore combining pandas with NumPy for advanced data analysis. So how we can do that is we can just import NumPy again. We imported it before, but just for showing you again. And what we can do is we can say array data, and we can just create an array like. We created a data frame at the start of this course from NumPy, and I'm just doing this again for remembering it. And by remembering this, we can just use NumPy arrays after now for creating data frames. We can say 7, 8 and 9, and then we can do like data frame NumPy. Actually there is an I need to do like, actually what is the error is that we need to take this to the start, and now we are good to go. We will say pandas.dataframe and we will give array data, and let's say columns are going to be sales A, sales B and sales C. We actually made a really similar thing to that at the starting of the course, and now we are doing it again at the end. Combining pandas with NumPy allows us to leverage the extensive functionalities of NumPy arrays within the pandas environment, facilitating complex data manipulations and calculations. We actually use NumPy arrays a lot on deep learning and machine learning models, so using these two can be really beneficial, and that's why I showed it again. I think you are going to use NumPy a lot if you are going to do a data related job, like you can be data scientist, data analyst, machine learning engineer, and I'm pretty sure you will deal a lot with NumPy. Now, as the final part of the course, we will explore the powerful text manipulation capabilities offered by pandas. Understanding these text methods is crucial for efficiently handling and processing textual data within your datasets. Let's begin by exploring how to use vectorized string operations in pandas. And we have a text data in here, and I'm just going to use df for displaying it. And let's lowercase this text data, like let's say data frame lowercase, and we can just do data frame text data, and we can use string.lower like this. And let's get data frame displayed, and you are going to see all the letters are lowercase. Also, let's do an uppercase version of this. So we can say data frame uppercase, and what we can do is data frame text data dot string dot upper. And here, when we display data frame again, you're going to see we have the uppercase letters in here. So let's make an example of checking for string containment. So how we can do this is data frame contains, and we will say data frame text data, and we will use dot string contains, and let's say letter P actually, and then we can do case false like this. And when we display data frame again, you are going to see that if the string contains P, the value we give in here, it will display true because we set the case as false, and if it's not containing P letter, it's giving false in this column. Using vectorized string operations allows us to perform various text manipulation tasks efficiently and seamlessly within the Pandas environment. Next, let's explore applying regular expressions for advanced text processing. So how we can do that is Dataframe matches, and we can just do eqsign Dataframe text data dot string find all, and we can just say oh, and we can just say Dataframe now. So it returns in a list all in the matches side if the word contains all, and it returns an empty list if it not. Applying regular expressions enables us to perform complex pattern matching and text extraction operations, providing advanced capabilities for text manipulation and analysis. Furthermore, let's explore using string replacement and splitting for text manipulation. And I think that will be all for our course. And let's do like Dataframe replaced. And in this side we will say Dataframe text data, we will say string replace, and let's replace the O with X. And let's see how our Dataframe replaced looks like. Here it is. We got the hello in different version. And now what we can do is for the splitting, we can say Dataframe split, and we can do Dataframe text data, and we can use string split like this. And let's just call it, and you will see that if we have multiple words like data science, they are splitted in a list like this. Using string replacement and splitting allows us to modify and manipulate text data effectively, facilitating comprehensive text processing and analysis tasks. And that was all for this course. Thanks for watching. I tried my best on this course. I'm creating data science and programming content. You can subscribe to my channel for more. I have a lot of courses on Matplotlib, Seaborn, NumPy, and a lot of topics in data science. You can check channel playlists or the videos for them. Also, if you want to make projects based on these libraries, like using real-world datasets, I'm providing data science project videos in my channel with the dataset I use on that videos. You can also watch that videos for having your portfolio with real-world projects and learning how to do projects by yourself. Thanks for watching again. Have a great day.